Okay. Now, welcome back again. We have a new chapter here. We have a talking about function. But first of all, briefly, I'm going to give you some clue about the function. Of course, we have a application of function, many applications. Maybe use it in your specialty about the growth, about the any chart that you have. Even pie chart can be imagined as a what do you say, as a function. So kindly you can find the application of the function if you try to solve at if you try to search it at whatever you like. And the function is the machine. We have an input output. Our 4.1 is just for information. Your question will be start from 4.2 sorry 2.1 2.2. So function is as we have as a machine. For example, we have a tomato and can, and we have a factory of the tomato paste or paste tomato. So how we organize that and how we get the output? We bring the tomato, we give the tomato and the can together to our factory. Then we will get a what would you say, tomato paste, and here's the result. So like a function, whatever you have, whatever you like, you are going to define the function, then the output will be depending on the function. As a part of the evaluating, for example, if your function is what? Is x squared 3, or let me give you the simple example. If you have f of x is equal to x squared, x squared f of x equal to x squared. Now, if I give f of 0, I'll get what? Sure, 0 square, right? If I say f of 1, I'll get what? 1 square. So I'll get 1. If I have a minus 1, of course, I have minus 1 square, and I'll get 1. When you have a value, you can substitute it. We are not going to use that one. I'm not going to ask you about such question like that, because it's very simple. You can just put it here, replace it here. So directly, I'm going to what? To the chapter 2 section. You can see from here's application, many application. Kindly just read it. Just read it at home to get more information. In the 2.2, we are talking about the graphing function by plotting, and the graphing of these functions that without using calculator. We have many functions, many type of functions. You can see. Let me open the button for you. Here we are. We have what? For example, if my function is what? F of x is equal to only x. How's the graph? How we sketch the graph? Yalla jam. Now that one, you will get one question from this lecture today. So kindly, yeah. What we have? Linear, right? So my function will be slant linear line, right? Like that. How we sketch that one? Maybe in the secondary school, we use a point. We say x, f of x, then the point x and y, right? We say if I put 0, I will get 0, then my function is what? Is just only x. I will get 0 also, so 0, 0. If I put 1, I will get 1, it will be 1, 1. 2, 2, 2, 2. And maybe minus 2, I'll get minus 2 and minus 2, minus 2. Then we plot all these points, which not actually is not accurate. It's just for understanding. We say 1 here, 1 there, 2 here, 2 there. Then 3, 4, 5, and minus 1, minus 2, minus 1 over x-axis. When I input minus 1 here, I'll get the output on the y-axis. It will be what? Also minus 1, and go on. Minus 2 here. Then you can see when you catch all this one, when you connect all these points together, you will get a shape. How about if, for example, if I say y equal to x squared? Now, you know, the mission is complicated, right? You don't need to find one by. So the shape is very important. Okay, dears? The shape is very important. How? We have, for example, we see the shape is like what? Concave or concave. Yeah, you are right. It's like a U. Let me say it's like a U. Understood. How about y equal to x to power 3? N is like, should look like n, you're right. Like that. It's coming to 0 and like that. How about n to power 4? Y equal to x to power 4. How? W? Dears? No. Again, is like U. That W got it. Later, I'm going to talk about it. Wait. If I have x to power 5, I'll get the same shape as n or as x equal to 3. Okay, dears? It will be the same shape. So generally speaking, general, if I have y equal to x to power 6, again, I have a U shape, but wider, a little bit wider. Okay. So how about W? Why they say W? Because in case if I have y equal to x to power 4 with something like 3x to power 3, 5x2 plus 1. In that case, you are right. I'll get W. And I know if it's minus, I'll get M. Will be reversed. Later, I'm going to talk about all this one. So the linear or the simplest graphs are like that. Pay attention kindly. Cheers. Okay. So generally speaking, if we have y equal to a number like 2, I say my function is what? Is a vertical line, right? Where y is 1, 2. So generally, you can say y equal to x squared or x, y equal to x squared, and go on. How about if I have y equal to 1 over x? Yalla. The shape of it. Because actually in 4.2, we depend on the shape. Like what? Yeah, you are right. That's a domain. You're right. How about the shape of the graph? Yeah, like a cusps, right? Like a moon. Part of moon is called cusps. It's like that, right? To C, like a C. We have a cusp or C. So in that case, I'm not touching the axis, actually, that like that. So this is the shape of y equal to 1 over x. How about x squared? Yalla. Exactly, you're right. That one is the positive part. That one is negative part. But because you have a square, the negative part is coming to up, right? The negative part is coming to up. The same that we have. And many else. Maybe we have y equal to square root of x. How about the shape of this one? These functions is called common functions. Okay, because later we are playing with them. Kindly try to learn. Yalla is equal to what? Like what? Like a, yeah, like a something like that. You can say v or different like. Clear? It's starting from 0 to infinity. Okay. Now how about cubic root? Cubic root. This part and that part. We have that part together. And how about absolute value? That is v. We have a v. Understood here? So if you like, you can use the summarizing all this things is talking about how to sketch. So you don't need to just look at the end of this section. At the end, you have all things that we talk about. So we have a linear, and linear like that, square to power 4 to power 3 to power 5, square root, cubic root, fourth root, fifth root, 1 over x square, and absolute value of x, and of course, forget about that one. Clear, dears? That one like a stairs called step functions. You can see it's like a stair, one back. Till here, all this is familiar to you. Am I right? No. What's the challenge in here, in this section, if you try to study? Let me give you also that one. Then later I'm going to talking about the challenging graph, how to sketch it. Of course, you have a line test, vertical line test. When we say vertical line test, is a test using for that to show you your graph is a function or not. So we have two concepts here. What and what? Two concepts, function and graph. Because all graphs are not function, but all functions are graph. What do you mean? If you ask me about these two, arbitrary, just I'm going to sketch it, I don't know that one. And if you ask me about that one, which one? A and B, first function, second function. Or sorry, first picture, second picture. Which one? Yeah, exactly. Which one is the function? I say because depending on vertical line test, which is a testing by vertical line, if it's intersect in one point, it will be function. If it's intersect in 2 points, it's not a function. So tell me, tell me that one is function or not? How about that one? Okay. So tell me about the graph. First one is graph. Dears? There's graph, yeah. How about the second one? Also graph. You have a graph, you can see. So the graph is not, it means the shape, the figure, whatever you say. Imagine or image. But the function knows the mathematics things. You should have vertical line test to check it. Understood, dears? That's talking about how to sketch it. Okay, now, generally speaking, ellipse or circles are what? Are not function, but they are graphs. This is ellipse, you can see, and that's a circles, you can see they are not graph. Sorry, they are not function. Now, as I told you, we have one thing challenging in 2.2. It's talking about what? Piecewise function. What do you mean by piecewise in Kurdish? We call as what in Kurdish? Okay. Okay, tell me about definition of piecewise function. We have two parts, paldar, two parts. First part and second part. How we sketch it, that's the question. Because in the exercise, actually you have it. And it's important for exam, of course. For example, I say my function, f of x, is equal to x and let me say x squared. When x greater than or equal to 0, when x less than 0. So how we sketch this graph? I say sketch the following graph. One of them is like that. How? First of all, in your mind, put it two functions because we have y1, y2. You can call it f1, f2, whatever you like. I'm calling f1 and f2. So this is f1, of course. That one is f2. So sketch f1. I say f1 is equal to what? Generally, y equal to x. How I sketch it? Straight line, right? Linear. Do you have any question about this first one? Dears? And then I'm going to erase all, no part of it. I'm going to erase this part. Why? because we have a condition here. He say not all. We have all, but count or remains those parts that the x greater than or equal to 0. So this green means that part. That's why I am going to erase the second part. Do you have any comments? Did you understand? Generally is like that. When I say x from, for example, if I say, sorry, if I say, for example, y equal to x, and I say x greater than or equal to 5, how we sketch this example? I'm not going to sketch all parts. It's not like that. No, I should start from 5 to greater than 5. So my graph will be start from here to up. The other will be erased. If I say sketch the graph, look, I'm going to change the example. If I say sketch the graph y equal to x, but x less than or equal or just all less than -2, how we sketch that one? At the beginning, I say this is the graph. But because we have less than 2, I say here's -2, my graph will be start with the green, that part. And of course, less than. So I'm going to erase the red part. There will be not red part. You got it? Good. So depending on this information, I'm going back to my first example. I have y equal to x, but when all? No, not all. This part remains. I should just sketch those parts that x greater than or equal to 0. Yalla, tell me about the second. It's your turn. It was another example to give you more idea, okay? To learn how to sketch one part. Okay, this was another example. That one's another example. Okay, dear? Good. Now, how about x less than 0? Where's the graph? Is what? Yes, let me use the black. Generally is like you. Am I right? Which part, but? He say what? Negative. Where's negative part? Here's to left, right? Am I right? Good. So I'm going to erase that part. Clear? Because we have only that part. So I'm going to erase like that. Now, did I ask you to graph two functions for me? No. I asked you to, to sketch these together. So we are going to join both of them. How? Let me erase that example because we don't need to. Now you are familiar with it. So I'm going to join these two examples together. How? I say here's the things. Here's the first part. And here's the second part. This is called piecewise function. Two functions or three functions together. Okay, look at your exercise. Look at your exercises. Here's. You can see we have many things from here. We have many things, 3-part, 4-part, whatever you like. We have many parts here, right? So how we sketch that one? They are easy. Yes, they are easy if you understand. Now going back to your lecture, I'm going to this lecture and talking about this graph. Here we are. So how we sketch this one? Yalla, it's your turn to help me. Yalla, dears. They give me idea. First, where's the critical point? 0, 1, 2, 3, 1. So we have a problem at 1. Am I right? Less than 1 is where? Left, right? This is less than 1, and this is F1. So how we sketch the F1? I say this is the graph generally. Am I right? Okay, now because we deal with first part, because we deal with just only first part, so I'm going to remove that part and fill it because we have an equality. Less than means that here. Am I right? Come on, easy, right? Now erase the blue part. Generally is U, but we try to just remain that part with 1. Understood? Good. Now tell me about the second part. Yalla, this is the first graph. Tell me about the second graph. How we sketch? We have an X, am I right? Sorry, we have an X like that. Then multiply by 2, a little bit slower than the other. Then plus 1, here's X. Here's 2X. Here's plus 1. Am I right? Plus 1 means that what? We shift to up. You're right. Then later we will take a shift up, down, right, left, reflecting about X, reflecting about Y later. But now just easy one. We have what? X plus what? 1. So my graph is like that. Will be my plus 1. X plus 1. Good. And all of these one are my graph or not? This line also all include or not? Not. Why? Because we have a critical point here. We have a point here is 1. And he say what? He say greater than 1. So my graph will be here. And I'm going to erase the blue one because I am counting for the second function here, for the second function, counting greater than 1. So it means that we have that one. Because we don't have equality, so we'll leave the gap like that. Understood? Now combine these together, function number 1 and function number 2. First graph, second graph, you will get such graph like that. And you can see it's easier, right? There is a question. May I ask? How do you know you start from here? Why you are not starting from here or there? Is my question clear? Why your graph start from here, not here, not there? Which equation? Exactly. So if I put 1, look at here. If we substitute 1, if I substitute 1 here, I'll get what? 1 square. If I substitute 1 here, I'll get what? 3. So means that I should start with what? 1, 2, 3, and 1. This point is what? It's 1 and 3. Am I right? How about this point? 1 and 1. Clear what I say? So to locate, to make your graph more accurate, you need to substitute the value that we have, the critical value. Clear, dears? Exactly. No 1. Critical point. Maybe 0. Anything. Okay? You got it, dear? Easy? Okay. Now, can you solve that one for me? Let me find one of them. Yalla, 33. Can you graph it? Yalla. تمام. يلا together. أمانين ولا كيسة كان أو رياض كيس تيت أو ثاني كمان good. Hey. Okay, look at here. How we solve that one? The first function, as I told you, we say, listen. We say y equal to 0. Where is y equal to 0? The function of y equal to 0 is where? X-axis, you're right. Is x-axis all is y equal to 0. We say is a vertical, horizontal line, right? Y equal to 2 is like that. Y equal to -3 is like that. Am I right? So this is the graph. Okay. Now, we have all x-axis. Okay. But we have a condition here. We have a critical point, 2. So I'm going to choose the 2 as a critical point in my mind. I see here's 2. And my question say what? Less than 2. So means that my graph should be less than 2. This is the graph. Understood? Not all axis, not the whole x-axis. No, from 2 to less. How about the second graph? I'm going to use the green or black. Yalla. We have 1. How's 1? 1 line, am I right? Y equal to 1, okay. But where? Greater than or equal to 2. So I'm going to erase the other part. Am I right? So this is your graph. You should do it one by one. You cannot control both of them. Yalla, dears. Tell me about... Yalla, that one. 14. 40. 40, yalla. It's a little bit... The level is a little bit higher. Okay, dear. Look at here. Look. First of all, you have what? Y equal to what? First function? -1. So tell me about -1. I say is... Sorry. I say is like that. Y equal to -1. Am I right? This is the graph. But where's the critical point? I told you to find or to write, to select the critical point. Where's the critical point? -1 and 1. You are right. -1 and 1. So on x-axis, kindly listen, on x-axis -1 and 1, there's a problem with them. I should break or connect or join my graph depending on those points. So he say what? Y equal to -1 when y what? When when x less than -1. Less than -1 means I start from here to the other side. So I'm going to erase the other part. If you are correct, good, you did well. Now, the second part, or let me say the easiest one, third part, is equal to what? Y equal to 1. So I'm going to sketch y equal to 1. Okay, but all of them, no, where's? There's something, the given. He say when x greater than 1. So where's when? Here's 1, here's greater. So I'm going to erase the less than 1 for the third graph. Now last one. Last one, I have what? I have only x. Where's the graph of x? The graph of x is like that. Am I right? It's like that generally. It's like that line, right? Good. So how we erase the part, I don't know, depending on the location. The location say what? Yeah, between -1 and 1. So I'm going to choose it as a green, between equalization with it 1 and -1. So I'm going to erase the black part that they are not belong to this. Generally, you will get that shape. So kindly try to solve that one at home again, as well those all exams, those all exercises. One of them, I don't know which one, will be for final, and one of them will be for the test. Understood? So kindly try to study all of them. Any question? Tears? Do you think it's clear for 2.2? Good. 10 minutes. I'll give you 10 minutes rest.